Hello everybody, this is the continuation of class 10 physics chapter electricity. In my previous video, we were doing the exercise questions of your NCERT book, and today we are going to continue from question number 11. Question number 11 is, show how you would connect three resistors, each of resistance 6 ohm, so that the combination has a resistance of first one 9 ohm, second one 4 ohm. Already we have done this type of questions. This time we are given three resistors, each of resistance value 6 ohm. Question, how will you connect them for getting the first one an equivalent resistance of 9 ohm? So we have three resistors, each of resistance 6 ohm, and we are expecting the combined resistance 9 ohm. Since all the resistors are having the same resistance, it is easier than the previous questions that we have done. There R1, R2, R3 values were also different. Then we have to think for different combination. This is comparatively easy. For getting 9 ohm, remember what I told you in the previous class, 6, 6, 6, and we are expecting equivalent resistance 9 ohm. If all the three are in series, you know it is R1 plus R2 plus R3, it will be 6 into 3, 80. If all the three are in parallel, then the combined resistance will be lesser than the lowest one, that is less than 6. So one thing is clear, neither all the three are in series nor they are in parallel. So the first possibility, now we have to think the combination of series and parallel. So for the first one, for getting 9 ohm, this is the case. Two 6 ohm resistors are in parallel, and the third 6 ohm resistor is in series with it. We know how to find out the combined resistance of this combination. For this 6 and 6, Rp is equal to, what is the formula? R1 into R2 upon R1 plus R2. Only for Rp, this is only for 2 Rs, this is the direct formula. R1 into R2 upon R1 plus R2 is equal to 6 into 6 upon 6 plus 6, 6 into 6 upon 12, 12 and 6 got cancel, 2, 2 and 6 got cancel, 3 ohm. So combined resistance of these two 6 ohm resistor is 3 ohm. Now this 3 is in series with this 6. So Rs is equal to, now Rs is equal to, combining them together, these two together is actually of 3 ohm. So now we can consider it as 3 ohm. So 3 plus 6. Rs is equal to R1 plus R2 is equal to 3 plus 6 equal to 9 ohm. So we got the first answer. In order to get 9 ohm, the three resistors are to be connected in this way. Clear? Now second, we are asked to get a combined resistance of 4 ohm. Now let's see how can we get 4 ohm by using the same three resistors. This time this will be the case. Two 6 ohm resistors are in series and the third 6 ohm is in parallel to this. So what is Rs of this combination? Here Rs is equal to R1 plus R2 is equal to 6 plus 6 is equal to 12 ohm. Now these two resistors can be considered as a single resistor of 12 ohm. Now this 12 and this 6 are in parallel. So what is Rp? Rp is equal to R1 into R2 upon R1 plus R2. What is R1? 12. What is R2? 6. So 12 into 6 upon 12 plus 6 is equal to 12 into 6 upon 18. 6 and 18 got cancelled, 3. 3 and 12 got cancelled, 4 ohm. So the combined resistance of this sequence is 4 ohm. Please see once again. 6 ohm and 6 ohm are in parallel. So we have calculated Rp. Now this Rp is in series with this 6 ohm. So the final formula is Rs. Here these two are in series. So first of all we will calculate Rs, equivalent resistance of these two. Now these two will become a single one of 12 ohm. That 12 ohm is in parallel with this 6 ohm. So we have used the formula of Rp. So I think we have done 3 or 4 questions of this type. So this is a very important type question of electricity. Clear? Okay. Now I am moving to the next question, that is question number 12. And question number 12 is several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. Rated 10 watt means power 10 watt. How many lamps can be connected in parallel with each other across the two wires of a 220 volt line if the maximum allowable current is 5 ampere? There are some bulbs, each of power 10 watt. They are to be connected in parallel so that from a 220 volt supply line the maximum current drawn is 5 ampere. So what are given? Given, this is question number 12. Given power of one bulb, that is P, or we can say P1 is equal to 10 watt. Now we are given V is equal to 220 volt. Listen, V is equal to 220 volt and power of one bulb is 10 watt. So what will be the resistance of one bulb? We know that R of a bulb will not change. So let us calculate resistance of one bulb. Resistance of one bulb. What is the formula for R, P and V? R is equal to V square upon P. So R is equal to V square upon P is equal to 220 into 220 upon 10. 0, 0 got cancelled. 22 into 22, 484. 0. 4840 ohm. So R of one bulb, resistance of one bulb is equal to V square upon P is equal to 4840. Now let the number of bulbs used, is equal to N. Given total I is given 5 ampere. In order to get maximum 5 ampere current, how many bulbs are to be used? And we have taken let the number of bulbs used is equal to N. So now I am going to find again R of N bulbs. Because now we have to use the formula for R in which there is I and P. P of one bulb is given 10 watt and total I is given 5 ampere. When they are connected in parallel, it can take maximum 5 ampere current. Then what will be R of N bulb? But remember, when bulbs are connected in parallel, V remains same. So we cannot use the formula involving I. What is the formula for R in terms of V and I? R is equal to, using Ohm's law, R is equal to V upon I. Is it? Here we have used resistance of one bulb is equal to V square upon P, because power is given. For a single bulb, only power is given. We do not know what is the I used by one bulb. We are given I used by N bulbs. So here we have used the formula V square upon P. Here we are going to use V upon I, because total I consumed by N bulb is given 5 ampere. So R is equal to V upon I. V upon I means 220 upon 5 is equal to 44 ohm. So R of N bulb is equal to 44 ohm. R of 1 bulb is equal to 4840 ohm. Now what is the relationship between them? N bulbs are connected in parallel. So we know the formula 1 upon Rp is equal to 1 upon R plus 1 upon R plus 1 upon R N times. Now what is Rp? Rp means total R of the circuit, that is this R of N bulb is called Rp, that is 1 upon 44. Now what is R of each individual bulb? 4840. So 1 upon 44 is equal to 1 upon R plus 1 upon R plus 1 upon R. N times means 1 upon R into N. Okay, I'll substitute the value of Rp and R in the next step. Now cross multiply. Rp into N is equal to R, or N is equal to R upon Rp. R upon Rp. R means individual R, 4840. Now what is Rp? 44. 4840 upon 44 is equal to 110. So number of bulbs used is equal to 110. I repeat, find the resistance of one bulb using the formula V square upon P. Then we have find out the resistance of N bulbs using the formula V upon I. Since they are connected in parallel, we have used the formula for Rp. 1 upon Rp equal to 1 upon R1 plus R2 plus R3, but all R's are same. So 1 upon Rp equal to 1 upon R into N. Substitute the value. So the answer is 110. I hope all of you got it. Okay. Now I am moving to the next question. That is question number 30. Question number 13 is, a hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the currents in all the three cases? I repeat, there are two heating elements A and B, each of resistance 24 ohm. These 24 ohm two resistors can be used in three ways. First one, they can be used separately, means A alone or B alone. Second, A and B can be connected in series. Third, A and B can be connected in parallel. In all the three cases, what is the current used in all the three cases? So what will be the first case? And everywhere V is given 220 volts. Case 1. when A or B is connected. When they are connected separately, means either A is connected or B is connected, only one is connected, both have the same resistance. So R is equal to 24 ohm. Now what is the formula for I? I is equal to V upon R is equal to 220 upon 24. 220 upon 24 is equal to almost 9.16 ampere. So the first answer, when A or B, means A or B, when they are used separately, each of their resistance is 24 ohm. So formula I is equal to V upon R. Now case 2. What is case 2? Series, I think. Yes, in series. A and B are connected in series. Then R1 is equal to 24 ohm. R2 is also equal to 24 ohm. Now RS is equal to R1 plus R2 is equal to 24 plus 24 is equal to 48 ohm. Therefore, I is equal to V upon RS is equal to 220 upon 48 is equal to 4.58. 4.58 ampere. Okay. Now case 3. What is case 3? When they are connected in parallel. When they are connected in parallel, R1 is equal to R2 is equal to 24 ohm. Formula for RP is direct. R1 into R2 upon R1 plus R2 is equal to 24 into 24 upon 24 plus 24 is equal to 24 into 24 upon 48. 24, 48 cancel, 2, 24 cancel, 12 ohm. So, only we have calculated RP. When they are connected in parallel, RP is equal to 12 ohm. Now, we have to use the formula. Once again, I is equal to V upon RP. So, we got RP is equal to 12 ohm. Now, the formula I is equal to V upon RP, that is 220 upon 12, and 220 upon 12 is equal to almost 18.33 ampere. So I hope you got the answer. First one, when R is used separately, R is equal to 24. Then V upon R, 220 upon 24. Second, they are connected in series. So V upon RS, 220 upon 48. Third, they are connected in parallel. So RP is equal to 12. Therefore, I is equal to V upon RP, 220 upon 12. Okay. Now the next question, that is question number 14. Question number 14 is compare the power used in the 2 ohm resistor in each of the following circuits. Compare the power used by a 2 ohm resistor in 2 circuits. The question is about 2 separate circuits. First one, a 6 volt battery in series with 1 ohm and 2 ohm resistor. So this is question number 14. In the first part, you are given a 1 ohm resistor and 2 ohm resistor are in series and 6 volt battery. One ohm and 2 ohm. I hope you understood the meaning of the question. A 1 ohm resistor and 2 ohm resistors are connected in series to a 6 volt battery. What is the power used by this 2 ohm resistor? Okay. When two resistors are connected in series, always remember V splits, but what will remain same? I will remain same. So in this case, in order to find out P consumed by this 2 ohm resistor, we have to use that formula of P where only V and V and P are involved. Is it? Because we cannot use the formula in which there is I. In which there is V. V across this and V across this differ. We cannot use the formula where there is V. We have to use the formula where there is only I. So what is the formula for P? P is equal to I square R. P is equal to I square R is the formula that can be used when resistors are in series. Because in series, I remains same but V splits. So, in order to find P, we require I square and R. R is 2 ohm. Because we have to find the power used by 2 ohm resistor. Now we have to find I. How to find I in series? I in series is equal to V upon RS. So here RS is equal to R1 plus R2 is equal to 1 plus 2 is equal to 3 ohm. Now I is equal to V upon RS. 6 upon 3 is equal to 2 ampere. Now we are going to use the formula for power. Therefore, power used. Therefore, power used in 2 ohm resistor. Power used in 2 ohm resistor. P is equal to I square R. Substitute the formula. I is equal to 2. So 2 square into R. R is 2. 2 square 4. 4 into 2. 8 watt. See once again. 1 ohm, 2 ohm are in series. So formula for power is I square R. For R is 2 ohm. So we have to find I. In series, I is equal to V upon RS. So this is RS. So I is equal to V upon RS. P is equal to I square R. Clear? Yes. Now there is a case 2. Again we are asked to find the power consumed by 2 ohm resistor. But this time they are connected in parallel. Second case, a 4 volt battery in parallel with 12 ohm and 2 ohm resistors. A 4 volt battery and 2 resistors of resistance 12 ohm and 2 ohm are connected in parallel. 4 volt, 12 ohm and 2 ohm are connected in parallel. This can be vice versa also, no problem. Now when two resistors are connected in parallel, remember V remains same but I separates. This is I1, this is I2. But what remains same? V remains same. So this time we have to use the formula for P in which there is V and R. So what is the formula? P is equal to V square upon R. Is it? Listen. In parallel V remains same but I splits. So here we have to use that formula where there is V, constant V. Now what will be the V of this circuit? 4 only. So power used by 2 ohm resistor P is equal to V square upon R. V square means 4 into 4 or 4 square upon R means 2. 4 into 4 upon 2 is equal to again 8 watt. So we got the same answer in the previous one. This is case 2. In case 1 and case 2, power used by the 2 ohm resistor is same. So remember the important point here. When resistors are connected in parallel, in order to find out P, we have to use the formula in which there is V, because V remains same. In the previous case, case 1, R1 and R2 were connected in series. In series, I remained same. So we have used the formula in which there was I. So this is the only change, only thing that you have to remember. So that's all for today. All the numericals are to be done by you, practiced by you again. These are the types of important numericals of this chapter electricity. So please go through this video once again, understand the numericals and do it by yourself. Thank you for watching the video. See you in the next video. Till then, bye bye and take care.